And then I'm going to show you a little trick. But we have to practice first, and then we'll get to the trick. Let's choose the next problem, please. If not, I will.
We do 49.
Yes, of course, 49. Let's continue with 49. In 49, we have log x, which is common log, which is base 10, plus 3 log y. Good. So first of all, we cannot change it like this because it has a number in front. But I know where this number is coming from. It's coming from the power of y. Because if I had 3 here, would I put it in front? So I have common log x plus log y to the third power. And now both of them have coefficient 1 in front, so this must be this. There is no other way. Let's go back. From here, I write this, and then the power goes in front as a factor. Any questions on this problem? Okay, let's choose the next one. I still think we need a few more before we move on to equations, which is section 4.4. Anyone would like to choose another? If not, I will.
Over 57.
57, very good, excellent. So in 57, we have 3 natural log x minus 1/3 natural log y. Perfect, excellent. As you know, I have to take care of the numbers in front first. So this is natural log x to the third power minus natural log the cube root of y. Because power 1/3, y to 1/3 is the cube root. Now there is negative between these two. So then this is natural log x to the third divided by the cube root of y. So let's go backwards and check. From here I have this, then I bring 3 in front, and then I bring 1/3 in front. Any questions on this one? I still think we should look at more.
We do 65.
Yes, of course. Let's take a look at 65. 65, 1/2 log base 5 of x plus log base 5 of y. Okay, minus 2 log base 5 of x plus 1. Perfect pick. Good. So of course, in parentheses, I have a sum. They have coefficient 1. I don't have to worry about anything. I have 1/2 outside, but when I condense this, I have log base 5 of xy. Log base 5 of xy is this plus this. Minus, of course, 2 is the power of x plus 1, because from here, I bring down 2 to get this. Good. Now I have to take care of 1/2. But power 1/2 means the square root. No problem. So log base 5 of the square root of xy minus log base 5 of x plus 1 squared. Finally, it's a difference. So this is log base 5 of the square root of xy at the top. If it has minus in front, it's going to the denominator. And this is it. What is this? All this condensed into one log with coefficient 1 outside, nothing else. Everything was taken care of. Any questions? Is this okay? So the trick, can I choose one problem now? Any questions on this? Okay, I just wanted to show you how easy this is if you know what, if you remember the properties. So I'm going to choose 69 or 70. You choose. You want 69 or 70? Because I want to show something. Which one?
We can do 70.
Okay, perfect. So we have log x plus log x squared minus 4 minus log 15 minus log x plus y. X plus 2. So the ones with plus in front have to be coming from the denominator, from the numerator. The ones with minus in front have to come from the denominator. This is it. So plus in front, numerator, negative in front, denominator. That was the little trick that I wanted to show you. Otherwise, you have to factor out -1. You have to condense this. And then realize that this product is coming from the denominator. Just remember this little trick. Positive in front, the quantity comes from the numerator, this and this. Negative in front, both of them have to come from the denominator. Okay, do you think we have now the idea of how this condensing works? If not, or if we just simply need more examples, please choose. If not, we'll move on, and I like to move on. We discussed this, but I like to evaluate using the change of base formula. I know the calculator allows us to enter now any base, but I would like to practice the change of base formula. So do we need more condensing, or we move on to the change of base formula? Please say something so we move on, or we pick.
Can we do number 65?
Of course. Let's do 65, but we just did 65. This one was 65. So we condense this, and 1/2 was the power. And then here we just move the power where it came from. And this has plus in front. The quantity is in the numerator. This is minus in front. The quantity is in the denominator. Is this okay?
Yes.
Okay, let's see if we need another. Maybe we need another. If not, let's choose from 71 to 78. If you're satisfied and you understood the idea with these condensing, with condensing logarithmic expressions into one log with coefficient 1. Nothing in front, in other words. We know it's 1, but nothing else. So if we're okay with the condensing, let's move on to 71 through 78, in which we apply the change of base formula. Anyone would like to choose, or I will? So condensing is okay. Please say something so I know what to do.
Yes, can we do 73?
Yes, very good. 73. So we have log base 14 of 87.5. Yes, as I said, the calculator now, the new calculators allow us to put in 14, but assuming that we cannot, not both. I'm going to show both, but you don't need both. So either common log of the number over common log of the previous base, not both, there is no need, or natural log of the number over natural log of the previous base. Both will give us the same number. What number? That we raise 14 to get 87.5. So this is a number. What number? 14 raised to this number equals 87.5. So, and we can check also. So I'm going to share and go to the calculator. So we either, not both, as I mentioned, I will show both though. Common log of 87.5 divided by log. This is not a property. This is not log of 87 over 14. It's log of 87.14 over log of 14. And natural log should give us the same answer. Natural log of 87, but this is the change of base formula, divided by natural log of 14. It has to be an identical number, 1.69, ta, 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 ta. Okay, so let me write down this number, 1.694407599. And how do I check? I raise 14 to the previous answer. No, that's not what I meant. I meant 14 power the previous answer. So I raise 14 to this previous answer. When I click enter, if I do not get 87.5, I did something wrong. But you have to copy the entire answer. If you put 1.69, you're not going to get 87.5. You're going to get something close. But if you tell the calculator to use the whole thing, like I just did, and you click enter, the answer must be fixed 87.5 sharp. But if I write 14 and the power, because I want to check 1.69, I will never get 87.5. I will get something close, but no way exact. Good. Do we understand how the change of base formula works? Oh, I didn't mean to do that. Actually, I meant to do this. Do we understand how the change of base formula works? And yes, there is that feature. You go to, I never use it, so I have to look for it. Log base 14 of 87.5. And yes, we have to get 1.69440, so on and so forth. Okay, do you think we need another example to illustrate the change of base formula? If you say yes, please choose. If not, we'll move on to exponential and log equations.